Dynamics with deterministic loading. The deterministic loading is known as at all instants of time. Is known at all instants of time. In contrast, we can only estimate the statistical properties of environmental random loading. Environmental loading is essentially random in nature. Linear sequence of random, we can see it. Structure may be regarded as a varying loading as amplitude of the load. In practice, this requires that a linear, if at any given frequency of science randomly, the displacement is proportional to the amplitude of any frequency. The deflections are small so that the static equilibrium equations are not significantly affected by the deflections. This implies that P delta effects are small and there is a high factor of safety against buckling. Material must be behaving in an essentially linear manner, that is, stress is directly proportional to strain, although the sum of the material damping is acceptable so that the part of stress may be proportional to the rate of change of strain. The mass must be constant. The number of degrees of freedom of a system or a number of independent deflections necessary to completely describe the motion of the system. The simplest representation of structure is to model its inertia as a single mass and stiffness as a single spring. The mass is assumed to have only in one direction only, so that only one deflection x is needed to fully define its position. The spring represents the stiffness of the structure, restoring the mass, and some of the examples of spring stiffness, various external forms are shown in table. The mathematical model is described as having a single degree of freedom. Even a model this simple can provide useful results for practical structures. Here you can see it. Deck, pile, mass. That's a mass. Pile is the stiffness. K represents the space stiffness of the pile as measured at the deck. M is the deck of the mass plus an allowance for part of the pile mass, and the hydrodynamic error mass, which is water which is effectively constrained to move with the pile. This is actual structure. This is the simplified structure. This is the simple dynamic model. Stiffness, mass.